All right. What up, everybody? There we go. Notes time. Grab that notebook. First page. I'm going to start to talk about some data displays. So let's jump right to it. All right. So as we start to look at this over the course of the next week or so, a couple of our learning targets, our goals, our objectives, however you want to say it. So one, we want to be able to choose the correct type of display, right? Choose the display for a given type of data. So categorical or numeric data, or one versus two variables. So we want to be able to pick the right graph for the right situation. And then the kind of the bigger of the two, the meatier of the two, we want to be able to create and interpret, so we got to know how to read them, one variable data displays, including frequency tables, which we'll see today, histograms, coming Wednesday, box plots, coming later, dot plots, coming Wednesday, probably too, Thursday-ish, and a couple others. All right, so we want to be able to know how to make these graphs. We want to know which graph is right for a given data set, and then we want to be able to read graphical displays and draw some conclusions. So before we get into the graphs, first up, so some vocab. So like in your notes, this is like the first thing you're writing today. Maybe I would give this the title, like, what is data? So we're just going to look at some general data vocabulary right off the bat. Like I keep saying the word data. What does that mean? So by the way, lots of vocab in this unit. So we could have some vocab-based assessments, some matching quizzes, multiple choice, and whatever, right? But vocab. So data. Data is just any information we collect. Could be measurements, could be categories with context. So data could be, I ask you, who's your guidance counselor, right? And everyone answers categorically with whatever, Mr. Jordan, Miss Barry, whatever. It could be, what's your GPA, right? And in that case, we have a measurement, something quantitative, right? Kind of measuring your performance. It could be a common one for like the US Census. What's your household income, right? That's a measure of something. Anytime we're collecting data, though, we always want to have context. And as we start to work through this unit, we always want to think about the context, the situation at hand. So a spreadsheet full of numbers with no context, that's not really data. That's just a spreadsheet of random numbers. But a spreadsheet of numbers labeled as whatever, test scores on unit 1, okay, right? Now we know what those numbers are about. Or a spreadsheet with a bunch of words, yes and no, right? What is that? But if we add some context, are you registered to vote? Now we know what those yeses and nos represent, right? So we always want to be thinking about context. So as I've referenced here, there's two kinds of data, right? There's the categories or the measurements. So categorical, which is sometimes called qualitative data, right? Those are synonyms, is any data, any information that's sorted into groups categories. So that could be a yes or no question. It could be an agree, disagree. It could be, what grade are you in? Freshman, sophomore, junior, senior. It could be, I don't know, who are you going to vote for in the upcoming election, right? So those are all categorical variables where your response is some category. What's your favorite sport? That's probably fairly obvious. Then we have quantitative data. That's our numeric data. So quantitative data, numeric data is a measurement of some kind. So that's a key word here, right? With some kind of measurement of some amount or quantity, and we also want to pay attention to units, right? So it could be the household income, right? A measurement of how much money a household makes, and our unit, of course, would be dollars. Could be your height with a unit of inches. Could be your weight, right, in pounds. It could be your score on a recent test. The unit there would just kind of be points. Could be whatever, free throw percentage in basketball, right? The unit would be the percent of free throws that you make. So all of those things are measuring something, right? So quantitative data. So as we move forward, we always want to be aware that there's kind of two worlds we're working in: categorical data, quantitative data, right? Both are important. That's it. Sounded like I had something else to say, but I got nothing. All right. So moving on, some vocab there. If you need time for your notes, that's the beauty of the video. Just press pause and jot down whatever you need to. So now we want to start to transition our focus to specifically the graphical displays that we can use for each type of data. So first, kind of create a bank of what displays we can use for categorical or quantitative data, and then we'll start to go through each in more detail over the course of the next few classes. So another little title here, displaying data, or personally, I think I'd go data displays. So let's do it. So one thing I want you to think about, so if we have one variable, whether it's one quantitative variable, one categorical variable, I want you to try to think about what graphs you might create. So for quantitative data over here, if I gave you a list of numbers, right? Maybe these are some recent test scores on an exam you're seeing here. What type of graph might you be able to make with those numbers? Maybe you're thinking about an assignment that was due last week on Thursday or Friday. Maybe you're thinking about some experiences you've had in other classes. I don't know, maybe some things you've learned in the past. Similarly, if we have categorical data, right? So if I ask a bunch of people, are you registered to vote? And then, right, the first person says yes, then no, 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 right? Hopefully lots of yeses. It's important we all exercise our right to vote. That's one of the ways we can take action and try to initiate change. But anyways, let's say I have a list of yeses and nos, right? And I want to summarize this information graphically. And so think to yourself, what types of graphical displays might you create? So I challenge you to pause the video and try to jot down some of these ideas right now. And as you unpause, right, of course, if we were in class, we'd be sharing out ideas and stuff, and it would be cool and fun. We'd be laughing, having a good time. A little bit different here. We'll do our best. So let's start with the categorical. You had a bunch of yeses or nos. What kind of graph could you make? It's like, oh, yeah. April, what do you think? And she's like, pie chart. Oh, good idea. Pie chart. I like that one. Definitely, right? Could have a nice circle, whatever. One chunk of yeses, hopefully a big one, and one chunk of nos. Then someone else is like, oh, who's that? Oh, Shaylin, what do you think? Bar graph. Oh, yeah, bar graph. Great call, right? We could have a bar for yeses and a bar for nos. Maybe you weren't thinking that because it was just yes and no, and you're used to seeing more bars. Our third option, this came up in yesterday's Delta Math assignment. We could create something called a frequency table. Essentially just a table that says yes, how many people chose yes, and no, how many people chose no. We call that a frequency table. There are other graphs we can use for categorical data. Those are the three we're going to focus on in this unit in this class this year. So if I say, what graphs can we use for categorical data? You got to know those three. Quantitative data. So now we got a set of numbers. What kinds of graph can we make for a set of numbers? And then I pause, right? And then like some people are like quiet for a little while. And I'm like, what about that assignment that was for over the weekend or for Thursday or Friday in our first Delta Math? And then someone's like, histogram. Oh yeah, we can make a histogram, right? A histogram is just like a bar graph for numbers. Another option, I don't know if you've seen this one before, maybe in science class, maybe, I don't know if this is new to us. We can make something called the stem and leaf plot. Another option we can use with numbers is something called the dot plot. We'll see that come up next class, probably. Another option, we can make something called a box plot. So a few of these, box plot, dot plot, I think, histogram, right? We saw those referenced in our second learning objective on the first slide. That's coming later. That won't even be this week. And then lastly, we could also make a frequency table. So actually the frequency tables you made in yesterday's Delta Math assignment were for numbers, right? They were for intervals of numbers. So a frequency table is unique amongst all of these in the sense that it can be used for both types of data. All right, so a lot of stuff to remember here, right? We got to know these. We got to know these lists. We got to know what graphs are used for quantitative data, what graphs are used for categorical data. There's the same slide, but not color-coded. I'm big on color-coding notes. So color coding notes is a great way to engage yourself in the content. It forces you to make some connections and kind of think like, oh, why is all this stuff blue? Because that all applies to categorical data. Or why are these things red? Right? So it makes us make those connections. And if you have to decide yourself how you're going to color code, that even forces you to think about the content more deeply and develop your own ideas about why, what colors you might use and where. So I love color coding. It makes the notes look nice, makes them look pretty and organized, which is great, but it really makes you think a little bit more deeply about this stuff we're talking about, right, which is a good thing. All about being engaged to the best of our ability, especially, right, in this remote setting that we're not all used to. Other situation. This isn't going to be a major focus in this unit, but we do want to be aware of that we can create some graphs if we have two variables. And so I know this came up last year in Algebra 1, probably a bit in science class even when you're like analyzing some lab results. So if we have two quantitative variables, we can create a scatter plot, right here, or a line graph, which is essentially like a scatter plot where we just connect the dots right here. And I think we're all pretty comfortable or familiar with this at least, right? For a scatter plot, we know we need two variables, right? Because we need our IV on our x-axis, we need our DV right, on our y-axis, and we start plotting points and stuff, right? So I'm pretty sure you guys make a bunch of these in science, and definitely came up in algebra. For now, just know that if we have two quantitative variables, two numeric variables, right, these are some options that we have. Line graph, great way to see trends and stuff over time. All right, let's start to get into some of the specific graphs. So a frequency table, that's really the big one for today. We'll just kind of touch on a couple others. So a frequency table. To the right here, you see two different examples of a frequency table. I want to jump back and kind of make sure I keep my colors consistent. All right, so I want blue categorical, red quantitative. And if we were in class, I'd ask people to kind of just point out, make some observations. You know, what do you notice about these two tables? How are they similar? How are they different? And so again, right, I challenge you, pause the video and start to think about those things right now. Maybe think about questions that you might have. You know, maybe there's something you're not sure what it means. Maybe this would be a good notice and wonder situation. Anyways, moving on, right, because we're not in class. So what do you notice about these? Both have frequencies. All right, that's important. What's frequency? Frequency is just how many times something happened, how frequently it occurred. Here we have tallies. This one didn't use tallies, whatever. The Delta Math assignment chose to use tallies. But the main thing I want to point out is here, right, we've got a numeric variable, number of pets, are also known as a quantitative variable. And down here, oh, I messed up my color scheme already, right? That should be red, I think. And down here, we have a categorical variable. So a frequency table can be used with both types of variable, categorical or quantitative. So down here, right, categorical data. If we're talking about a frequency table with categorical data, maybe I even do this, categorical data, frequency table. It's a graph that shows a list of the categories and how many values or responses showed up for each category. So this is an example of a frequency table for categorical data. And I've chosen to put those words in purple because those are actually the definition of frequency, right? So frequency is just how many values or responses were in each category. That's something we can also refer to as the count. So those mean the same thing. We're literally just counting how many things are in each category. With quantitative data, a frequency table, hold up, it's bothering me that my color scheme isn't consistent at the moment, so I'm going to go with the red. I'll go -- frequency table. Is instead going to show us a list of intervals or values and how many pieces of data, I guess, just because I don't want to overuse the word values, fall into each interval. So, right, the reason we could have intervals in our Delta Math assignment, the frequency tables were like, you know, how many are from 0 to 4 or 5 to 9 or 10 to 14 or whatever. And that's what we'll see in the example for a second. But this here is just a specific value, right? How many people had 0 pets? How many people had 1 pet, 2 pets, 3 pets, and so on. I mean, ultimately, you know, let's not make this too complicated. It's just a table that lists the categories of the possible numbers and how many of each occurred. So let's not overthink it. This slide may be making it too complicated. So let's make a couple frequency tables. So let's say I asked people, you know, what's your favorite sport? Football, basketball, soccer, baseball, none, or other. And right, so like as we go through and we start to get responses, we can tally what people say and then list the counter frequencies. So if we were, you know, let's pretend we're in class, we're like, Shaylin, what do you like? Basketball. And then it's like, I'm trying to think, who else? Raid, what do you like? And he's like, soccer. And then we got like Rasheen, what do you think? I'm pretty sure Rasheen told me he was on the basketball team, right? So I'm really testing my get to know you brain here. And then McWill, I could be wrong, but I'm pretty sure McWill had a bunch of soccer players on his GM board, I think. And then whatever. It's like Mr. Carafano, he says football, and then whatever, and so on and so forth. So it's like baseball, I don't like any sports. Football, soccer, football, badminton, curling, wrestling, Muhammad says, whatever. Another football, another soccer, right? So we just tally each response as it comes up. mean, some people don't even like use the tally thing, right? So if you don't know how to tally, when we get to 5, it goes 1, 2, 3, 4, cross for 5. And then so then we just list the count for each, right? So we got 5 people said football, 4 people said soccer in this made-up situation, 2 basketballs, 1 baseball, 1 none, and 3 people said other. So this is a simple frequency table showing each category, each possible response for your favorite sport, tallied them up, and then how many people said each. And then someday in the future, we could get crazy and add a percentage category over here, but we'll hold off. That's it. Don't overthink it. How about if we had some numbers? So let's say I ask how many siblings you have, and we get these responses, this data set right here. Now, for the number of siblings, right, we could list each of these individually, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, or we could use intervals, 0 to 1, 2 to 3, 4 to 5, and so on. And there's like no right answer as to what the intervals would be. I just picked 0 to 1. This could have said 0 to 2, and then 3 to 5, right? So there's not a right answer as for the interval. So again, there's my little timeout right here. I challenge you to take a timeout, pause the video, look at this data set at the top, and create this frequency table yourself in your notes. Like, do that right now. And as we look through, right, so we can kind of go through here. So we got a 0, so one of those. We got a 1, so right here. We got a 5, a 9. Whoops, that was a bad cross out. We got a 2. We got a 6. Another 2. We got a 1. We got a 0. We got another 1. We got a 2. Another 2. Another 2. A 4. A 6. A 4. A 3. And a 10. I would have liked to color code those for each, but I'm trying to keep the video short and sweet here, or shorter and sweeter, I suppose, than longer. So we got 5, 6, 3 of these, 2 of these, 1 of these, and that's a really sloppy tick mark, but that's one of those, right? Just this 10 over here, I think. That's it. So frequency table, just list each category or different intervals and how many data values fall in each category or each interval. Right? So what we're seeing on the screen now, this happened in our Delta Math assignment. It's pretty much it for frequency tables. Moving on. Bar graphs. You got that. You know how to make a bar graph. We'll have some practice questions. There's sometimes some SAT questions where we have to read a bar graph, so we'll kind of take those as they come. I'm not going to focus a ton on making a bar graph. We'll have some examples come up, but I know you got that. You can make a bar graph. You've probably been doing that, you know, since you were little. One thing we do want to be aware of, we can jot in our notes, is we do want to be aware of these. So in your notes, you can just comment, right? Bar graph, side-by-side bar graph can be used to compare or show multiple pieces of information. So these are used pretty commonly. Like here, we're looking at percent literacy by continent and gender. And so this is showing us, like in Europe, right, we can see males, females have about the same literacy rate, which is why the overall one is the same. Whereas like in Africa, we can see that the males, right, have a much higher or whatever, somewhat higher literacy rate than the females. You can also see that the males have a higher literacy rate than the overall population, right? And hopefully you're thinking that's because this black bar has to be somewhere in between the males and the females, roughly kind of like the average of those. In Asia, or maybe think about this, right? Pause the video in a second and think, for which countries is the literacy rate higher for men? For which country or countries is the literacy rate higher for women? Oh, I'm sorry, not countries, continents. That was embarrassing. I know my stuff, all right? I went to 5th grade. Which continent is the literacy rate higher for males? Which continent higher for females? Give it a pause, something to think about. So we like a side-by-side bar graph for comparison. Pictographs, they use pictures. These two people, these are pictures summarizing how we feel about picture graphs. They're gross. Here's why. They're kind of hard to read. Like these are 2 graphs showing the same information. Which one's easier to read? If I say how many students littered 7 or more times, would you rather look at part of a trash can or just look at this and you're like, oh, I'm pretty sure that's 2? Or if I said, how many students littered 1 to 3 times? We got to think like, all right, that's 3, that's 3, that's 3, that's 1. Not that it's super hard. It's just not as easy as looking at this. Also, for the sake of comparison, this is just cleaner. Like we can easily see which is the lowest, which is the highest. And again, not that we can't see those things in the picture graph, it's just easier to tell with the bar graph. So picture graphs, oftentimes, they just make things look distorted, which is one way that graphs can be used to intentionally mislead people by using pictures to maybe distort comparisons between groups. Those are the kinds of things we'll think about as we move through this. I think that's it for today. We're going to save dot plots for tomorrow. So have a wonderful day. Make some frequency tables, finish up your Nearpod, and that's it. I'll see you guys soon.